Hello. Hi, welcome to the 12th live session of quantum topology 2. This is Shavik, and right now I'm going to research on Gaussian Murray matrix. Okay. So, by the information, this is not the last live session. The last live session will be on next Saturday, from 7 to 8 p.m. Okay. So, okay, so since from last 3 or 4 live session we have started solving assignments including objective and subjective for rules. The answers has already been released. So today also we'll continue in the same direction. So first we shall go with the objective assignment of week 11. Then we'll go with the subjective assignment of week 11. Okay. So first of all, let me tell you clearly that today we shall discuss the objective assignments along with the detailed solution that has been shared by Sir. Okay. Also, one more thing is that for some questions there may be more than one possible solutions, but we shall try to go along those solutions which has been posted, okay, so that you can easily understand. Okay. So let's start. So one second. Okay. So let's first start with uh, okay. So let's first start with assignment 11 objective type questions. Okay. Yeah. So week 11. Yeah. So the first question is as follows: if X is Hausdorff, then the function space y to the power x is Hausdorff for any topological space y. Okay, this is the first part. Okay, so first let's think about how to approach this problem. Okay, so first of all, y to the power x is what? The function space of what, where function mass from y to x. Okay. Now, given that x is Hausdorff, we need to check the y to the Hausdorff or not. Okay. So, y to the Hausdorff or not. So, well, I mean, sorry, but unfortunately, there is no way to visualize this answer. So, you need to uh, keep in mind that this is answer is false. Okay. So, for that, which counter we may choose. We can do we can take x equal to any set of two elements, that is we can take x equal to 1 comma 2 with a discrete topology, okay, and y we are taking double dot AB with equal space, or we may choose any non-Hausdorff space, okay. Then obviously y to the power x is homeomorphic to y cross y. It is clearly not closed. Clearly not closed. Okay. That's all. So we take two sorry we take any x with two set any x with two elements, x equal to 1 to the switch topology, y equal to second bracket AB with constant space and any non-Hausdorff space, and y to x equal to y cross y to which is non-Hausdorff. Okay. That's all. Y to x equal to y cross which is non-Hausdorff. Okay. So that's why the answer is false. Okay. So that's all. I mean, this type of question you can't really visualize, so for that you need to practice more, and without practicing you can't really understand how to approach this problem. Okay, it is difficult actually. Okay, so let's move into the next problem. For any two topological space x and y, theoretic an embedding of y in space. So So what is the question? For any topological system, there was just embedding y inside CXY. Okay, that means what we need to do, that is y can be embedded inside CX. Then you need to find g such that g of such that the such that g reach real embedding. That is g is homeomorphic onto it. Sorry, y is homeomorphic onto its image gy. That's all. So how to do it? Okay. So one possible way to do this is the following. So look, we have some x, okay. So we put something like y1, y2, y3, dot dot dot. This is countable, but maybe uncountable also. So this is one possibility, but this method will not work. Okay. So how? Or we can do y belongs to y, okay, and define a fy from x to y, so that fy y is equal to y for all x belongs to x. Okay. So this map may work. Now there is a possibility this can work. So we are defining map y to cxy. Y goes to cy constant map where cy x is equal to y for all x belongs to x. Okay. Now claim is equal to g tilde equal embedding. That means you need to check what g tilde is 1 1 and g tilde is homeo onto its image. Okay. Now what to do? How to check 1 1? Injective. How to check g tilde y1 is equal to g tilde y2 and c of y1, c of y2, you can only c of y1 x, c of y2 x for all x belongs to x. These is the y and y2. So this implies zero is reactive. Okay. Now what are we going to? Okay. Now we need to check g tilde is open map as well as continuous, right? This is what we need to check. Correct. So okay. So first of all, in CXY, what is the open set? Open set looks like 3 by 3 comma 8. Okay. So what case is a compact set using open set, and this contains all those a, so a for k sub of q. Okay. So now we check g tilde inverse k comma u is open or not. Okay, right? Now g tilde k comma contains what? This contains all those y y such that cy belongs to third bracket k comma u. Clearly equal to whole of q. Okay. Why? Because y belongs to y, cy sub of k is open index. K is open index. K compact. So this implies y belongs to y, so Vyx belongs to u for all x belongs to k, and this is equal to small y. So this is equal to all. This is what? G tilde inverse k u is equal to u. Okay. So what? So so this implies what with open? So this implies what? This implies G tilde is continuous. Fine. Now let's check openness. Okay. How to check openness? So let u be open and y. To show. G tilde is open in this. Okay. So now that means what? G tilde is what? It contains all the small u belongs to u such that u belongs to. Okay. And this is obviously equal to what? Clearly it is singleton x comma u into friction shift. So which is open. So this is what? Given a G tilde opening. So this implies what? This implies G tilde is opening. Um, sorry. G tilde is an open map. Okay. So this is there is a G tilde open map. G tilde is continuous, and we have seen previously that G tilde is injected map. So these together tells that the G tilde opposite. So this tells that G tilde is unvaried. So this is that's okay. So let me let me okay. So first let me again discuss the solution. I think that's all. Right. So okay. So for any topological space x and y, there already is an embedding of y in place y. This is the question. You cannot answer this true or well. So the answer is true. So what is the map? So obvious map is for each y we're choosing a function of x to y, which is constant map at smaller. Okay. So this is the function into I goes to small y. Okay. So that the now claim is G2 is an embedding. So so Pyx is equal to y. This is for all y. Now claim is a G2 is embedding. So for this, what we need first, we need to show the G tilde is 1 1. Then we need to show G tilde is homomorphism, and I mean G tilde is a homomorphic contours image. This is what we need to show, correct? So first, let's go the injectivity part. So let G tilde y1 is equal to G tilde y2. This is if and is cy1 equals cy, if and all is cy1 x equal to cy x for all x. This implies y equal to y. This implies G tilde is injective. Okay, so injectivity is done. Fine. Now let's now we need to check two more things: openness and continuity. Okay? So the continuity first goes here: G tilde inverse third hierarchy comma y. Basically, all the y and y such that cy belongs to third hierarchy of y. This is equal to what? This is all the y and y plus cy k subscript u. Because this is by definition. And this is equal to all those y belongs to y, so cy x belongs to u for all x belongs to k, and this is equal to exactly equal to small y. So this is equal to u. So G tilde inverse hardware k comma is equal to small u. So G tilde continuous. This G tilde continuous. And the last thing is openness. So let u be open in y. We need to show G tilde u is open in x. So now G tilde u is equal to c of u. which is u belongs to u, and this is the third bracket x comma u intersection z is open in z. So this is G tilde is open. So G tilde is embedded. So that's all. Okay, understood? You understand? Yeah. Okay. So that's all. So that's why. So y can be embedded in cxy. So it's true. Okay. So these are okay. Now the third question is as follows. Any two topological spaces x and y that are square straight, y calculate y belongs to y and dy to the y. It is closed in y to the y. Okay. So how to do it? So as mentioned earlier, this type of problem it is not easy to visualize. Okay, so that's when we practice more and more. So the answer goes as follows. Oh, kindly wait. Let me find some other solutions too. The solution given in the model is a bit complicated, so let me search for other solutions. Kindly wait. So, okay, so the solution, okay, the solution is two words. So, first of all, the answer is, okay, we don't know answer, so let's, so first of all, answer is false, okay, so let's get into the counter example. So, take any x to be a set of two elements, so let's take x to be 1, 2 with the discrete topology. Y is single term and topology or any non-homogeneous. So let's for the non-homogeneous space. Okay. So now, as in the first problem, the non-empty open sets of y to the power x r, y to the power x. This is equal to nothing but g comma c a. All of which contains, everything contains cf, which shows y to the power x minus x. One that. So how this argument goes? So the answer is false. So construct we we need to choose some counterexample for this. So take x to any two ordered set. I mean sorry, x to any set of two elements and y is equal to double down AB, which is a non-empty homogeneous space. Then non-empty open sets avoid the x or avoid the x, comma those things. And observe that each of the open set avoid the x contains c suffix a. So y to the x minus h can't be open. So the given thing can't be false. So the answer is false. Okay, so this is the argument. Now let's go into question 4. So the question 4 says if x is non-empty then xy connected, then y necessarily connected. So this is the question. So first, think about how to approach this problem. So okay, so this type problems are not actually obvious to guess. Okay. Okay, so first of all, let me tell you that the answer is false. The answer is true. Okay. So we need to prove this. So the question is how to prove. So question finally right. Hmm. So what to do? So look, the thing is, so it is given that uh, CXY connected. Now check the wires connected or not. Okay. So one possible way to do this is the following. Namely, we can make from from CXY to Y. We can make up. You can give a map which makes right. I mean CXY to we can give a map to the eventually Y. Then we continue. Then we are done, right? So further what to do? Define a map PX projection map CXY to Y given by Px small f is equal to f. These are continuous projections for any x. So, so So, so defining my px of small a is equal to this. So, that is extraneous. This is only what this implies y. Right. And this is projection also is continuous. So, continuous image of kind of is connected such that the map cxy from px to this is subjective. Okay, so that's all. So I mean that's all the problem is. So basically px is interconnected, so we need to construct a map from cxy to capital Y, so that I mean that which is subjective and continuous. So then you are done. Okay, now let's go to the next problem. Next problem is follows: if x is finite, then product topology correct open topology on y to the power n. So now, so the thing is, if x is a finite set, then product topology and compact operator y is the same order. Okay, this is the question you need to answer. So what to do? Okay, by the way, for the last problem, I forgot to mention the answer is true. Okay. Okay, so here also the answer is actually true. So how to do it? So first of all, anyway, product topology. First of all, by the theorem that has been done in class, it's clear that um, Oh, really wait, let me look for solution first. There is some confusion I'm getting actually. Can wait. Okay. So, okay. So first of all, observe one thing that compact open topology is finer than the product topology in multiple words. Okay. So this is one part. So now for converse part, let K subset of X be compact. Okay. Now since X finite, this implies what? K is equal to some X1, X2, X3. Okay. For some Xi belongs to X. So this implies what? So for any open subset U of Y, hard bracket K comma U is equal to point all of x1, x2, xn, comma u, which is nothing but intersection of phi xi inverse of u. I is equal to 1 to n. Okay. For phi x is a projection map onto x's component. Okay, so this is the argument. So this tells that third bracket k comma u is open in the product topology of y to the power x. Okay, so the argument goes as follows. So first of all, the compact open topology is finally the product topology y to the power x, and k to the, and also on the for the converse part, let k subset of x be compact. Now since x is finite, so k is nothing but x1 is xn for some xi, and this states that for any open u subset of y, third bracket k comma u is equal to this thing, and this is equal to intersection phi x inverse u, and this tells that the projection map by x projection map onto the x component. Okay, so this is the argument. Understand? Okay. So well, first of all, this proof is not obvious. I mean, it's not. This proof is not natural. Okay, but anyway, uh, this is not a difficult proof. If you have any doubt, please let me know. 1 minute, or you can ask me in the last upcoming live session on the last next practice. Okay. Okay. So now the next question. So question machine. If y is infinite, with cofinite topology and x. Okay, so the answer of the answer of the first part is true. Okay. If y will infinite the cofinite topology, then x be any topological space, then the xy is connected. Okay. Okay, so we have done one problem, namely CXY connected in fact Y connected. This is the converse. So first of all, converse is not true in general. If Y is finite to the cofinite topology, infinite to the cofinite topology, then CXY will be connected. Okay, and of course Y is cofinite, Y is cofinite topology means it's itself connected. Understand? So this is partially, I mean, this is partial truth about converse would have a problem. Okay, so now, so the question is what to do and how to do. So the answer of this question is given to be true. In the first statement at the answer is true, but then how to approach this problem? So the thing is, so we are claiming that any two non-empty basic open set in CXY intersect from which activity follows. Okay, so let K1 consider the intersection of the options K1 comma U1 intersection, K2 comma U2 intersection, KL comma U, and call it B1, and B2 is equal to K1 dash U1, K2 dash U2 dash, Km dash U1 dash. Okay, for some compact subsets Ki Kj dash of X and some open subsets ui and uj dash of y. Now e1 is equal to y minus f1. Daughter ul is equal to y minus fl. e1 dash is equal to y minus 1 dash. em dash is equal to y minus f dash. For some finite subsets f1, f2, fl, f1 dash dash 1. Now if we choose y0 belongs to y minus union of fi I is equal to mod to L, union of fj dash j is equal to mod to m, then we get cy0 belongs third bracket k1 comma e1 intersection kl intersection k1 dash 1 dash dot km dash kf dash. Okay, and this is nothing but equal to d1 intersection p2. Okay, so it's connected. Okay, so that is our argument. So let me let me repeat that. So the solution goes as follows. So we need to candidate or not, right? So that is we need to any basic not open set intersect. So the candidate follows. Okay. So we took two non-open sets, V1 and V2. K1 intersection E1, K2 under KL in K1 dash and E1 dash under KL in dash. For the compact sets K, KY, KI, KI, KJ dash, and for some an open subset UI, UJ dash. Now U1 is equal to Y minus F1 and UN is equal to Y minus F1, E1 dash is equal to Y minus F1 dash, UN dash is equal to Y minus F1. That's for some finite subset F1 F. Now if we choose Y0 belongs to Y and this, then we get C10 belongs to K1, K1 or KL and this one. So this is equal to B1 and B2. That's why the connected argument, so that's what the connected argument goes follows. Okay. So this is it. Okay, so that's all for the objective questions. Now let's go with the subjective questions. Okay. Okay, so let me find the subject. Me, sit down first. Okay. So let's go with the okay. So let's do the subjective aspects. So the first question is as follows. So if x equal to double done AB equipped with risk topology and y is T1 space, then show that CXY is homeomorphic to Y. Okay. So how to approach this problem? X equal to double to maybe equal to the sequence of topology and y is a C1, but then show that Cx is homeomorphic to y. Okay. How to approach this problem? So, so first of all, observe that since X is symmetric space, sorry, so any continuous map from X to Y is the constant mapping. So, for if X to Y is continuous, map such that A is equal to Y, then a singleton Y is closed. So F inverse singleton Y is equal to X. And this tells that F is equal to Cy, that is a constant map of Y. Okay. So therefore the map theta from Y to Cxy, Y goes to Cy is the bijection. Okay. And also for U open in Y, hard bracket X comma U is nothing but hard bracket singleton A comma U, which is equal to hard bracket singleton B comma U, and this. The U is equal to hard bracket X comma U, and theta inverse X comma U is equal to U. So theta is a homeomorphism. Okay, so this is that. Because of this argument. So, so, so basically, let me repeat. So, X is a two-point set, which is the truth topology, and Y is given to T1 space. Now, we need to show that Pxy is homeomorphic to Y. Okay. So, how to do it? So, since X is a continuous map from X to Y, and since X is space to space, so any continuous map from X to Y is a constant map. So this implies what? This implies if X is any map from X to Y, constant map, so that if X is Y, then singular one is closed. So this is what if it's singular one is whole capital X. So this says that it is a constant map, so Y. The map theta from Y to C from Y goes to as bijection. Okay. So theta is a homeomorphism. Okay, so this is the argument. So theta is a homeomorphism. Okay, so this is the full argument. So now let's go to the next problem. Show that if X is any topological space and if Y is equal to double dot AB through the space, then we need to check that Y to the vertex. So I mean, essentially this is the previous because we have checked X, Y, to Y. So that's why you can connect it anyway. Without using this can be done as follows. So kindly wait. So let me think. Is there any other alternative solution to this? Kindly wait for a moment. Okay. So the answer that has been given in NVIDIA solution right now. So we are going to follow that. Okay. So let's get subset of X the compact. Okay. So this implies what then the third bracket K comma singleton A and third bracket a comma y contains the constant element c suffix s, and therefore y to the power x is connected. Okay. So this is the argument. I mean, there is nothing really much to say. But initially I was trying that whether can it be done by defining some map. Okay. Okay. So let's go to the next problem. So the argument is like, oh, so the next problem goes as follows. Okay, so k is such a complex set. So third bracket k constant is an a is equal and third bracket y contains the constant of c. So therefore, what are the brackets connected? Okay. Now let's go in the next problem. Okay, so So the algorithm. Okay, so let's go to the next problem. So show that if X is a discrete space, then for any Y compact open product topology y to the power x. So how to do it? Okay. Okay. So the thing is, if X is not discrete, then for any space Y, the compact topology, product topology on Y is the best. So, so what? How? So the answer for this first. So since first observe that we have observed something earlier, that compact open topology is finer than the product topology. Right. Now to see this, now for the converse part, let for the converse part, let K subset of Y be compact. Okay. In compact Y, compact Y, X. Now what is discrete? K is equal to x1, x2, xn for some xi belongs to. So for any xi belongs to x, and for any open subset u open it y, third bracket k comma u, the third bracket all those x1, x2, xn comma u, which is nothing but intersection phi xi inverse u. Okay, and this gives the projection map. Except for this tails, third bracket k comma u belongs to the bulge or white. So these are so do note one thing. This argument we have done, we have seen in the objective assessment. So this is the same thing we are taking again. So argument. So let me search in for solutions. Oh, so let me repeat the argument. So let case of is equal. Now since x is discrete, so we can take x equal to, okay, so let me go to first which we have. Okay, so first of all observe that the compact component is finite. Okay, so one part is done. So whatever the converse. With the converse part, let's observe the following. Let case of x be compact. Now as x is discrete, so k is hardware x is different for some x and belongs. So for any xi belongs to x is substrate open, hardware k comma u is equal to x1 x2 x n comma u. And this gives a projection onto x component. This tells hardware k comma u belongs to the product topology of y to the power x. So yeah, so this is the full argument. Okay. So yeah, so that's all. I mean, there is nothing really too much, but you need to practice things as more as you can, so that these things can you can make you can quickly in exam. Okay. Oh, so now let's go for the last problem. Let x, y, z be topological spaces and let theta equal to x be continuous. Then show that you say the continuous theta star from cxy to czy defined by theta star small f is equal to f compose theta both equate to it open to college. Okay, okay. So how to approach this problem? So let me repeat the question. The x y topological space theta is to x be continuous. Then show that theta and b is the continuous of theta star from c equal to c z y defined by theta star x left composite. Equal to compact open topology. Okay. So basically, what we need to do is the following. So basically, we need to check the x star is theta is a continuous space. Okay. So how to do? So take k subset of j be compact. W subset of one open. Now if now since theta is given to be compact and sorry k is going to be continuous and k is given to be compact, so theta k is a compact sum of x. Okay, and now if belongs to theta e star inverse k comma w, if and only if theta star f is equal to theta compose f belongs order k comma w. This holds if and only if f compose theta k subordered. This holds if and only if f of theta k subset. This holds if and only if belongs to k composed. This tells that inverse image of basic open sets are of basic open sets under figures. So theta star is equal to this. Okay. So this is the argument. Okay, so now I think it's the right time to do the revisions. But wait, let me search is there any more questions that I found here. Tiny bits. Let me search some more questions actually. Oh, so let's go. Let's start. So the first problem is that X is a house space. Then the question is y to the power x a Hausdorff space or not? Okay. So as we have indicated, so let me repeat it again that it is not directly possible to say anything. So that's why there are some these are some techniques we need to always keep in mind. Y to the power x can be written as y to the power y and not possible. So this answer is in general false. So for that we need to consider counterexamples. So first use x to be a set of two elements, x equal to 1 to y is equal to double dot ab is specific space any Hausdorff space. So the y to the power x is equal to y cross y. It is not Hausdorff. Okay. Now second question is so yeah for any topology of space x and y, your resistant bearing of y and cxy. So how do we do this? So so first of all, the thing is how does it work for each y belongs to we can consider a map small f such that f is constant map to y. That is f of x equal to y for all x belongs to x. So this is the our map G tilde. Yeah, so this is our map G tilde, so the cx for is equal to x. Okay. Now our claim was the following. Yeah, G tilde embedding, G tilde 1 G tilde 1 image that is G tilde on sorry G tilde open. This is what it is. So the injectivity goes as follows that G tilde y1 is equal to G tilde y2 is equal to cy1 is equal to cy2 is equal to cy1 x equal to cy2 x. So you can y and y is equal to G tilde h. Okay, so G tilde is open map, right? Okay. As well as closed map, okay. So G tilde now so the injectivity is done. Now need to check the continuity. So G tilde inverse hardware k comma y contains all the y and y such that cy belongs to k comma hardware k comma u. Where k is open to compact. Okay. So now cy belongs to third bracket k comma this y belongs to y such that cyk subset of u. This y belongs to y such cyx belongs to for all x k. And this is equal to q. Okay. Now let u be open in y, then g tilde u is open in x. So g tilde y is equal to third bracket small x comma u intersection z open in z. This implies g tilde is open. So that's a zero embedding. The third question is for any two topologies with x and y, the subspace set cy x1 y belongs to y here with x is closed in y to y. So this is false one. So for that, let's start with the two space x and y. So order x equal to 2 and x equal to 1 comma 2 discrete topology. Now since y is equal to thing double point a comma b, it is also non-into open sets. So this implies y is equal to this root of c comma a. So basically this tells this what this part tells that the point C belongs to each of the open sets y to the x. This is not what y to the x minus x can't be open. Okay. So that's why z cannot be closed. So this answer is false. Okay. And the next question is, given that y is non-empty and cxy connected, and then y is necessarily connected. So for this, the main technique is to understand that from cxy to y to projection map, namely for each x, namely Px is equal f is a continuous map and continuous surjective map. So y is connected. So because the continuous image of a connected and surjective map, so its image is whole of capital as y. Okay. Okay. So next question is, suppose x is finite, the product topology compared to open topology are same order. Okay, on y to x minus. First of all, observe that the compact open topology find the product topology 1 to the x. So one side is done. So now for the converse case of this compact, now this order of x is finite, so k is equal to x1, x2, xn for some x, and then for any subset u of y, third bracket k comma u is equal to x1, x2, x u. So this is equal to intersection phi xi comma 3 So this implies phi x and intersect phi xi u. So it's on to the xth component. So third bracket x comma u is okay comma product is open in a product topology. Right. So that's all. Okay. So let's end the today. Let's end today here. If kindly go through this video. If you have any doubt, please ask me in the next live session. Okay. The next live session will be on Saturday, 7 to 8 p.m. Thank you.